Welcome everybody to your first online Algebra 1 lesson. Mr. Anders here. Hope you guys are all doing well. All right, so you should have already watched the other video on how to get to the website my.hrw.com. If you didn't, go ahead and click this link that's right up here. And that will bring you to that video first. So I'm not going to show you that in this video. How to get to the website, but or how to use it. There's also a video. The video talks about how to, what these different buttons do for you. The screen here is going to look a little bit different than yours. This is like the teacher side, but that's all right. So yeah, another thing you might want to do too is make the window a little bit bigger so you can see the buttons down here. Okay, so what we're doing this week is learning how to graph quadratic equations in vertex form. We did this actually back when we were in the building. A lot of people are absent though, so this might be new to many of you, but it'll be reviewed to most of you. And so these equations, look like this. And in just less than a minute here, I'll be switching over to doing a lot of this on paper. I don't have the ability right now to sort of show, write on my screen or show my writing somehow on the screen. I don't have that equipment. I'm hoping to get that, but we'll see if that happens or not. So for today, I'm just going to switch over to paper. If you want to, also, you are able to print the problems on paper. I don't know if you have this print all option or not. That might just be me, but you can print individual problems, and that might be handy to do if you have access to a printer. If not, you can certainly do this all just right on the computer. All right. So yeah, what I'll do a few examples from this homework, and then it'll be up to you guys to do this and get it submitted by Friday. And then also on by Thursday, I think I said 1 o'clock, I forget exactly. If you guys have any questions about this assignment, be sure to email those to me. I plan on making another video, which I'll post on Friday morning, to answer any questions that you guys have about this assignment. All right, so let me switch over to showing this on paper now.
All right, so we're going to learn how to see what would the graph of this equation here look like. Now, I'd highly suggest as you're watching this video that you take notes. Okay, it's a little awkward to, when you're working on the problems, come back to the video, find the right spot. All right, so I highly suggest, just take a piece of scratch paper and take some notes. Now, you'll notice I don't have any like grid down here or anything to graph on. I am not going to assume that everybody has the ability to print stuff out, so I don't want to use graph paper. I'm just going to show you, how to graph this, without graph paper, or at least to think about what would the graph look like. Okay, so this, remember, is in vertex form. In a vertex form, that looks like this. All right, you have some number here, we call that A, and then another number here, H and K. And then H is always the X value of the vertex. K is the Y value of the vertex. Okay. Now, what is the vertex? All right, I know it's been a little while since you've seen this, or maybe you never saw it because you were absent the last couple weeks of school. So the vertex, when you see a parabola, it's sort of that very lowest point, or it could be the highest point, depending on which way the parabola is going. Parabola is just what we call the shape of the graph. All right, so yeah, vertex there or there. All right, so the equation actually tells us the coordinate of the vertex. Now A, we'll get into that a little bit later where that comes into play. All right, so that means for this particular problem, my vertex is +1, -4. Now you might say, whoa, why is it not -1? But how it works here, again, looking at the formula, we have a minus here. And what that basically means is whatever value this variable is, h is the opposite. Okay, you can think of a minus as meaning the opposite, right? So even though this looks like a -1 here, h is actually a +1. K, though, is just the same. K is the sign you would expect. This looks like -4. That's what K is. That's the y value of the vertex. All right, so that's what the vertex looks like. Now, what we're going to do is just start sketching a graph. Again, I'm not going to assume people have printers and can print out grid paper, so we're going to do this the old-fashioned way, all right? And so we'll just do that for now, and try to make your spacings as close, as even as possible. But that's okay if you're a little bit off. We're just kind of getting a general sense of what this graph is going to look like. And then when you do the problems on the homework, that's going to be multiple choice. You get to pick, right? So 1, -4. Let me plot that. So 1, -4. All right. Now, it'd be nice to have at least one point on either side of this vertex. So what I'm going to do, I'll make a little table. And I'm going to put that in the middle. And then we'll go ahead and just go one x value down and one x value up. Now, if you're here with us in the building when I did this earlier, I did 2 points, but I'm trying to make this a little simpler given the limited resources we might have here. All right, so we're just going to do 1 point on either side, one x value on either side. All right, so in order to figure out, okay, what is the y value? What you can do is you can actually just plug in 0. What I'm doing right now is just one method. I'm going to show you actually another method later, but there's just one method, so you put in 0 into the function. So actually, let me write out the function again first, just so you can see what I'm doing here. So g of x equals 2 times x minus 1 squared minus 4. That's the original equation. And now I'm going to plug in 0. Now you could use a calculator to, you could put that whole thing into a calculator if you want. I might just do it in steps here. And that's going to be 2 minus 4 is -2. Okay, so 0, -2 is another point on the graph. And then we just do that also for putting in this other x value of 2. So let me do that over here. G of 2 equals, I'm just going to plug in 2 wherever I see an x in the original equation. All right. Let's see, we're going to get 2 times 1 squared minus 4. That's going to be 2 minus 4. That's also -2. Now, that's not a coincidence that these came out to be the same number. If you recall, these parabolas, they go down and up or up and down. So looking 1 point over, one x value to the left and one x value to the right, you should be at the same y value, the same level, right? So yeah, either way, if it was going up or down. So 0, -2, and then 2, -2. All right, so now we have at least a sense of what this would look like. We know it's curvy. You want to make it curvy. It would be best that we get another point on either side. That would just, again, I'm trying to just simplify this process a little bit, but you can kind of at least get a sense of what points this goes through, and that'll help us identify which one it is on the problem. So now when I go over and I just printed out a problem from my.hrw. Now your problem one might look different. HRW generates new numbers for the problems. Okay, so yours might be a little bit different, but it's the same idea. So let's take a look at the graph I sketched here and see which one does it look most like here. Well, it has to go. Now, unfortunately, another thing here we got to be careful on HRW. You'll notice the scale here. You got to be really aware of that on the website. These are actually going down by 4s, right? And then the x values are going by 2s. So really what might help is to actually write in what those coordinates are, and that'll make things, I think, a little less confusing here. So this was 1, -4. This was 2, -2. And this is 0, -2. Okay, so that'll help a little bit. And now let's see. Let me just take a look at this first graph here. Let's see, 0, -2. Is that on it? Oh, yeah, it looks like it is. That's 0, -2, right? Halfway between 0 and -4, that'd be -2. And then let's see, 1, -4. Oh, yeah, that's on it too, because yeah, this would be 1, right? Because this is 2, looking at the grid here. Okay, and then 2, -2. Yep, that's there. Okay, I got lucky. It's A on this one. Okay, but if if I were looking at another one, you could definitely see it. Wait, is 0, -2 on here? No, definitely not. So you could eliminate that one, right? There'd be some other ways you could eliminate some of these, and maybe I'll talk about that on a future problem. But that's how you would identify that. So so A would be our answer here. Okay, you would click that on the screen, and then it says the function has a blank value of blank. Part of the directions said give the minimum or maximum value and the axis of symmetry. So if you have a graph that's what we call concave up, like it's going upward like this, you're going to have a minimum. If we had a graph where it was concave down, you would have a maximum, a highest point, right? We in our graph here, though, we have a minimum because it's concave down. We have a lowest point on our graph. So the function has a minimum, is what you would select there. All right, and then it has a minimum value of, now a lot of times we're looking for the coordinate here, but I see HRW just wants the y coordinate of the minimum. Okay, so the minimum is actually going to be the vertex. I mean, if we think back here at our sketched graph, it was 1, -4. So that's the minimum. However, when you type this in, it's just really interested in the y value. Okay, so you're just going to put in -4. The axis of symmetry, that is the line that goes right through, it's vertical, and it goes right through that vertex. All right. Now, in order to write an equation for this, we go x equals, and then whatever the x coordinate this lies on. Okay, the x value, every point on this line has the same x value. And it would be the same as the x value of the vertex, which is 1, right? So the axis of symmetry is x equals 1. All right. All right, I'm not going to do a full example of number 3 here, but I wanted to mention one thing about it. You'll notice this looks quite a bit different. It's still in vertex form here, right? It's still in that same form that I talked about on number 1. But it looks like it's a lot shorter. So, what's going on here? Well, basically, we can see where H is here, but it looks like K is missing. So when you identify the vertex, what this means, well, okay, first of all, we have a +4 here. Remember how H is always the opposite. So H is actually -4. And since K is missing, well, in a way, you could write that if you wanted to, and you're not changing this side at all. So K is actually 0. So basically, if H or K are missing, it's going to be 0. So let's take a look at number 5 also. When you identify the vertex on this one, when you go to graph it. So you got to be careful here. This might, at first glance, look like H, but actually, looking again at the form of, I'm going to keep doing that. H happens before the squaring happens. Okay, so if we sort of line this up here, okay, the what's missing is H. Okay, in fact, if we had x minus 0 squared, well, that would be the same thing as x. So really what's happening here is H is 0, K is -8. All right, so we have 0, -8 as the vertex. All right, and just like we did on number 1, if you use the paper method, you could make a little table and just pick an x value before it, an x value above it, and figure out what those y values are on number. Now again, these problems might look different than the ones you actually get. They're going to be similar, but and then like on number 3 here, you'd make a little table. So notice I'm always picking one x value before, one x value after, and that can help. All right.
All right, I want to show you one more method really quickly too, if you weren't a big fan of doing it on paper like that. You can also use Desmos. So I brought this up, and of course, every time it generates a new problem. So this one's a little bit different than the original one I did on number one here. But let's actually type this in the Desmos and see how we can do it that way. So I don't think there's a way to copy and paste it, unfortunately. Oh, maybe there is. Okay, we'll see how that works. So I'll go ahead and copy and see if that ends up coming out in Desmos nicely. All right, so we'll go over, open a new tab, and go to desmos.com. And mine automatically goes to /calculator, but you probably don't have that yet. You can always just click Start Graphing, and then, yeah, there's the /calculator. All right, so let me go ahead and paste, see how that works. This might not work. Okay, it didn't quite work. So just be careful copying and pasting. This should be squared, not just a 2. Now, in order to put in that this is squared, you can use this and just do a squared, boom, just like that, okay? Um, and you can, I think you can just leave it like this. You don't need to put g of x equals. That's fine. You can see that it graphed it. So you can kind of use the graph, and you could even see like, well, this might not work so well by using the x-intercepts here we see, because there's decimals. So I'm going to get rid of those. But you can see where the vertex is, and what do we call this here? The y-intercept. So you could use those 2 points to help you identify which one of the graphs we had. Oops, where'd that go? There it is. Here, okay. So again, um, wish you could zoom in here, but unfortunately you can't. So you might just kind of have to do your best here. Looking at Desmos over here, we have, yeah, 1, -6. So let's see, 1, -6. Looks like that maybe dips down to 6 there. You definitely can eliminate A, right? That does not have the right vertex. We can also eliminate B because this is concave down, and we can see clearly this is concave up. Um, and let's see, this looks like, so 0, -4, it's got to go through -4. So it looks like this one does not, this one does, okay? So that's another method you could use if you want to, all right? So this basically, again, what Desmos does, it just plugs in a bunch of x values and graphs it for you, okay? So that's a handy tool to have. Let's go ahead and finish this problem, and I'll check my answer. So the function has a minimum, right? Because it has a lowest point here, as opposed to like this one has a highest point. So it has the lowest point, and the value of that would be, well, we can see on Desmos here, it would be -6, the lowest y value on it. And the axis of symmetry is just going to be that imaginary line that goes right through the vertex, and vertical line that goes through the vertex. It's going to have the same, this value here will match the x value of the vertex. So it's going to be x equals 1. So check the answer. Yay, I got it correct. All right. So that is another method. All right. Okay, so that's it for this video. If you guys have questions, please email me either about, the platform, my.hrw.com, how if it's not working, or of course about the actual problems like, hey, can you go over number 4? Can you go over number 6? And then I will create a video for Friday that'll go over those problems. All right, so please reach out. Feel free to email me if you have any questions. All right.